Alright, so in today's video I'll be showing you this tutorial. I'll be going over all of the steps in detail, so if you're interested in learning how parametric design works with Grasshopper, this is going to be a perfect tutorial. But if you also don't want to go through the whole video and just want to download the script, this will be available until the next video is posted. That way you can see how everything gets plugged in and you can learn a little bit more about how this design functions. So with that being said, thank you very much for being here. Hopefully you're excited to learn a little bit more, and let's jump right into it. Alright, so the first step is going to be to create an arc. So let's bring in the arc component. So for the arc, we're going to have three different inputs: the plane, the location, the radius for the size, and the angle for the segment of the arc that we'll create. So first we'll use a construct point, so we can use a parametric point as the location. We can also change that later on. The radius, we'll use a slider. So let's go here to create a slider for the radius. And the angle is going to be the angle that this is created at. Now here is the thing. 45 degrees for the angle. Notice that it's not working. And the reason for that is that the input is going to be in radians. So we'll go here to a component called radians, and what's going to do is turn degrees into radians. So let's go to 45 degrees. Now plug this into the angle. Now I should create a custom slider here. So either edit the slider, or we can do 0 less than 180 less than 360, giving us a slider of max of 360 and minimum of 0. We can also set a snap, so we can go here to edit snapping and then just do 45, 90, and 180. Now we have kind of these snapping amounts. Great. Okay, next we're going to create the subdivisions. So actually first we're going to move this up. So let's go to a move component. The motion is going to be up in the Z direction. Then the height, we'll use a slider. Next thing is we're going to take that geometry and we're going to divide it using divide curve. And let's use a slider to pick the number of subdivisions. So next we'll take this and we're going to move them up in the Z direction. And on this one, we'll use a slider as well to move it up. Now notice that when we move this up in the Z direction, since we're only plugging in one number, it's going to move that up by the same number for all of them. Now what we want to do on this one is understand how many points we have. So when we divide it by 5, we actually create 6 points. So we'll do 5 plus 1. So we know if we have 6 points on the output, we could have 6 here. Why? Because we're going to use, well, there are two ways to do this. Number one is by doing plus 1, since we know that it always adds 1, or list length, which when we plug in those points into the list length is going to give us how many items we have, which are 6. So these two can be used interchangeably. And now we'll use a random component. We need 6 numbers. Now we need to create the range. So the range is going to be here using construct domain. And now we can use a slider. So we'll use 2 different sliders. One to create the minimum, 0, and the maximum to be, let's say, 45 or 48. We can also go to a negative here. So do minus 100. So it could go down and go up at the same time. So let's just copy this new slider that has from negative 100 to positive 100. And the seed is going to be important because if we want different solutions, then we can kind of cycle through different iterations. So notice that we have 6 numbers starting at 15, but if I move this, it's going to start at negative 31. And if we have this one, minus 27. So now we can use this random number as the height. We'll delete this one. And now we have these as the old points and those as the new points. Now notice that when I move this around, it's going to randomly move them up and down by picking random numbers between minus 56 and plus 42. And if we have more points, it'll just create more that are randomly placed through the arc here. So now that we have this, we're going to recreate this curve. And we're going to use an interpolated curve going through all of those points. And now we can visualize how this randomly goes up and down depending on how many subdivisions we have. Oh, so this is the seed. How many subdivisions? This is going to be for this one. And then the maximum and minimum. So this can go down, this can go up, or the opposite. So the reason why we did this is because we're going to take this arc and we're going to loft it between the bottom one and then the top one. And I'll flatten the input here. Now I want to see if we can get rid of these creases here. So we're going to see if we can rebuild this first curve and see if that will give us a smooth curve, which it does. Now, when you rebuild a curve, it might ask you for different inputs, but if you have something like an arc that is a pretty consistent shape, then you may not need to change so many of these inputs for the rebuild. So now we can visualize this by going here and changing it up, maybe making it even less drastic, just changing it by little, or even adding more points. So I do want to keep it fairly simple. I do also want to kind of minimize some of these changes and then see if I can pick an iteration here that looks good. So I think I like this one. Also, remember that we can go back here and we can also change the angle. So like if we want to have a small opening or a large opening, this is going to be a design that only has one one entry, and then the overall size. For this next part, we're going to subdivide it using Lunchbox. So if you don't have that, you can download that for free on foodforrhino.com, and then you should be able to then access this tab called Lunchbox. And I'm going to be using under the panels, we're going to go to hexagon cells. Now we're going to divide it into U or V. So let's use a slider here. It's better if we start with smaller number of subdivisions than, a very large one. So let's go here to 20. Let's go 4. Maybe this one, 30. Okay. And you can do the same thing that we're going to do to this one with any other pattern. You just have to keep in mind a few things. So now that we have this, let's hide the original surface. Now notice that we have this pattern applied to it. And what's great about this is that we can always go back, make adjustments, and the subdivided hexagons are going to react to it. So let's go and see if we can find, I think I like this one. Okay. I will create a larger opening here. Maybe something like this. So now that we have this, we're going to turn this pattern into a solid. There are different ways to do this. I've done using pipes before, but what we'll do is take the cells and the center of each cell, which is this, and we're going to use a scale component using the centers as the center and then the geometry as the hexagon cells. Notice that by default, this component has 0.5, which means it's going to be scaled down to half of the size. So let's create a slider here between 0 and 1.000. So we'll start here by using 1. So we want to keep the first one the same, and then copy this, and also copy the slider, and then make the other one a little bit smaller. By scaling both of them 1 by 1, keeping it the same, and 1 by 0.8, then these two are going to be organized the same way, and we can just hide the inputs for this one. Now that we have this and the offset to the inside, we can loft it together. So loft this one and this one. Now notice that the wires are solid, which means that they are all one long list. Same with this one. What we want to do is graft both of the outputs. This way, the first one of this one is talking to the first one of this one, and so on. So that will make it so each individual cell will loft together. And now we have this slider being our overall frame size. Now next is we need to create the depth of it. So this part is where it gets a little bit complicated, but if you've been following along and you've done it up to this, you can definitely create the depth of it. It's not that big of a deal. There's, like I said earlier, there's a few things to keep in mind. First thing is we need to offset how deep we want this to be. So I want it to offset to the inside because I want the size of the radius to be the outside face. So offset to the inside, and then let's use the slider here to offset this to the inside. Now, all we need to do here is recreate the entire design that we have here, but on the inside to create the inside face. And so Since we already have all of the steps created, this is where when you see a script and it looks really complicated, sometimes it's the fact that you copy the steps. And so that makes it look more complicated. So we have to recreate what we did with this one, but do it to this one. So the way to do that is copy all of this. But the things that we don't need to copy are going to be the sliders, because the sliders, we want the, let's say, the height to be the same on the inside and on the outside. We want a few things to be consistent, like the number of subdivisions. So all of this is going to get copied except for the sliders. So taking all of this, sliding it down, tapping Alt. And now instead of this arc being the input, so we have two of these, we have this one and this one. Now all we need to do is override it with this curve. And now when we look at this one, so we have the offset curve, this one is going to go on this one. Notice that the exact same thing that we did for this outside curve, we did for the inside here. And some of these wires are definitely going to be messy. So that's why the ones that I copy, it's okay if I disable the wire display so we don't create a mess. And here, the same subdivisions. So this way it lofts together and it comes together into a solid without having any issues. Okay. So we have the outside, we have the inside. Now we're going to, now that we use this for the loft on the inside and outside, we're now going to loft between these cells, the first set of this one and the first set of this one, creating the outside. And now we're going to do the same thing for these two sets, creating the inside. Now we're going to join the B-reps using B-rep join. Now we can hide this and then go here and then bake it. And now if we take all of this and move it over here, you'll see that now this is a solid frame that's been done only by offsetting, creating a surface on the outside, doing the exact same thing on the inside, and then creating these connections in between. So for this next part, let me show you a few things that we can do to this design. So what I noticed here is that when we turn it into a solid, it's also creating these segments that are not solid. So what I want to do now is create a frame around this to kind of encapsulate the pattern. So let's do that. Let's go back to our curve, the base curve, this one, and the top curve. We're going to extend both the start and the end of the top and bottom ones. So let's go here to 12. Let's just do 24. So extend the start, extend the end. Same with this one. And the type, we're going to use an arc. The type is going to be an arc. Now we can use this to extrude up. So the bottom one, actually I'll put this one at the bottom. The bottom one will extrude down. So we'll extrude that curve using a negative component, a Z vector to extrude down, and then using a slider here for the base. And now we'll do, actually before we extrude it, this one and this one. And then we're going to do this. Instead of extruding it, let's see, we're going to move it this one down, and then the top one is going to be up. But I'll lower this. And then here between this one and this one, using an endpoint component, for both this curve and that curve. Actually, to simplify this, let's just use one height for the frame. So we'll use this one, and then using a line segment between the start and the start, creating this line segment, and using the end and the end to create the end of the line segment. Now we can hide these. And join them together using join curves. Or actually, no. We don't need that, actually. We can just loft together these two. Next is taking this and doing offset on curve, on surface, I mean. So the loft is as the curve input and the surface input. And now the offset needs to be by using this exact number, 24. And now that we have the loft and the offset, now we can use surface split. Using the loft surface as the input, then the curves as the input here. Now we can pick just one of them. So one of the segments is going to be the outside frame, and now we can hide this. Notice though that we only have the outside. Now we need to do the exact same thing that we did to this, but to the inside. So how do we do that? Well, we have both of these curves as these inputs. All we need to do is copy. So let's make some space here. We need to copy this back down without copying the sliders once again. Now, what we can do is use this input to here and this input or this output into this input. I want to see if this worked. Or did I plug them in backwards? So this one Where does this one go? The bottom one goes to the top, and the top one goes to the bottom. So I did it backwards. Okay. So now we have the inside portion, the outside portion. And let's see if it will let us loft these two together. Let's see if using graft this one and graft this one, we can loft this one and this one. So we're going to have to go the long way here and go to list item. Or a curved component. Let's try that first. Okay, didn't work. Then brep edges. And then brep edges for this one. And then loft both the outside naked curves and outside naked curves using graft. So notice that now we have that frame going around. And now this distance is going to be how far? Because we're going to now take this and these two and join them together. So it's a closed brep. And now let's use here. First, let's go around and make sure that things are looking good, which they are. Now we have the outside frame. We can also change that size. This one too. Oh, notice that I copied. So these and these are the same. Technically, that's how it should work here. So using 24 and then using the same 24 here. So double clicking here, creating this relay, and then just using this input. Okay. Now let's take a look at what this looks like. So we'll go here to custom preview. A color swatch. And now let's go in here and change this. Okay, there's that one. And I do like to, at the end of the design, kind of use a geometry component, group it so I can see it displaying some color. You can change the color by changing the color and then making it default. And next is going to be this one. This one. Cool. Okay, so we've kind of reached the conclusion of this. Like I said, the important thing about when you see something kind of complicated, just understand that a lot of it is copying the steps. So I do like to clean it up using hide the wire. And if you get stuck somewhere or you're like, man, I don't know how you got to that spot, if you're subscribed and you're watching this video when I post it, you should be able to download the script for free for about a week until the next video is posted. And you can check it out, download it, see if it works, see where you kind of made any mistake, or if maybe I did something different in this video. All of it will be in the site. So let's go here to delete this one. The idea with these is to kind of show you a few different tips and tricks. Not every video is going to be the exact solution of what you're trying to do, because there are sometimes a lot of different ways to achieve something. So I just try to show you different projects, different things that can help you kind of understand how this program works. A lot of it just comes down to like more trial and error, working things out in your head, kind of understanding workflows. So I'm just here trying to clean up a little bit. This way, when you download it, you'll understand exactly how everything kind of plugs in. All right, so now that we have everything kind of cleaned up, let's organize it. Let's figure out what the labels are going to be for the slider. So this one's going to be the size. On this one, it's going to be the angle. And I like to group my sliders so you can see which ones are the ones that kind of need to get updated. This is the depth. This is going to be the height. These are the divisions that make it more complex or a little bit more simple. And then min max for the random. You can also keep it the same. If you use the same number, it'll just be consistent. And then here, taking this one, grouping it. Actually, we don't need to group that one. And here is going to be the U and V division. So this is the pattern. And then here we have the frame. This is going to be the pattern. Now, on this one, here's the catch. If we take one and we actually change it to be smaller, there's actually going to be a gap. So that could be useful in some cases. But on ours, we do want it to be a solid. So this is where we do want this one to be consistently 1. And then we can also right click here and go to internalize data. Notice that the wire kind of goes away, which means that if we do the same thing with this one, the wire goes away. And now that number is always going to be 1 in here and 1 in here. And then this pattern is going to be the more like the offset. All right, so that basically concludes the tutorial on this. I'm going to save this in my files and then have it available for you guys to download. But at the end here, I did want to play around a little bit with what we came up with to show you a little bit more in depth as to how to use the script. All right, so the most important thing on how to use a script is if you can even change the location of where this is at. Now, by default, we see here that we have the X, Y, Z coordinate at 0. But let's say if we use the slider and we said 25 for the X. Notice that it's going to move it by 25 in the X direction, or by whatever number here. We can also pick a specific point within Rhino. So if we take this point and put it out here, all we need to do is go here and use a point component. Go to set one point, select that point. Notice that it will turn green. And now when I select this point inside of Grasshopper, it's going to select it within Rhino. And now we can override this point, either by creating a relay and overriding it, or just overriding this point directly into the plane input. So now notice that this point that we have here in Rhino is going to be where that is located. So let's move this to 0. So now it's at the origin point. I also placed a scale person here so we can see overall the size and proportions of this. I want to also see if we have the ability here to replace this hexagon cells with any of these other patterns. So first of all, we need the center points. Or even this triangulated one. Now, the only thing that is different between this hexagon cells and other patterns is that for the other patterns, you may not have the center. So you may have to extract that yourself. So let's do this. I'm going to save this one as 2. So this is like the second one. Do this for the first one. Just want to make sure that the files are organized correctly, and do a save as, and then save it as 2. So this is going to be, if we were to use a different pattern, how would we do it? Well, first we need to create relays for the where these come from. Then take this and delete it. So it will break it. Now let's go back to the triangles. We'll use the loft as the input. We do need the midpoints, so we'll use an area component. The U and V will use the same inputs. Let's move some of this stuff over, some of this stuff over. And now that we have the panels and the centers, now we can use the panels for the geometry and then the centroids for the center. Let's see if that will give us. Now the reason why this is not working is because it's trying to loft 2 options that don't work right now because we only have the triangles ones. So now let's use the panels. And then we're going to do the same thing with this one. Copy these 2 up here. Use the same inputs. Use the geometry, the planes, and then the centroids as the center. Now this should be working. Now let's go back to this one. Let's hide all of this. And let's increase the offset for this. The only thing I'm seeing here that is not working are these top panels. because there's a bit of a gap between the top and the bottom. We could just fix that by changing this input number. Basically intersecting those like this. But it won't look as good, so and notice that there's a gap here as well. So yeah, this solution doesn't look as good as the other one, but definitely worth giving it a try here. Okay. Let's give it one more shot, but let's try something different. Let's try, instead of using these, we'll use isotrim, divide domain squared, and then an area component for this one. So the area component is the center. These are going to be the surfaces, and then this is for subdividing it. So using those, and then using these inputs. Let's move this over. And then doing this same thing here. Basically doing the same thing, but with a different pattern. The U and V counts need to also be updated here. All right, I think this looks really good. The only difference is this one can be a consistent number here. Now we can hide all of this stuff. And notice that with isotrim, it does work. So I'm going to save this as option 2. This could be a really cool library as well. So a place to like store books and stuff. And then here, let's go back and see if we can change the size of it. Okay, and then the divisions. So let's see, 24 and then minus 24. Trying to make it drastic so it looks decent here. Okay. All right, so for now we're going to now just end the tutorial here because I've shown you, for the most part, everything I wanted to show you in this tutorial. The idea was to show you more than just one pattern, also how this one looks. I actually think the hexagon one looks a little bit better, but you'll have both of these options in case you wanted to see a little bit more about this script. So with all that being said, thank you very much for being here. Like I said earlier, if you want to download the script to see if you got stuck somewhere or just to see how I created it here, you can download that from my website, capettidavid.com. So thank you very much for watching, and I hope to see you in the next video.